Dear students, welcome to the knowledge series. Here we are going to discuss on artificial neural network building blocks. As you know that artificial neural networks are powerful computational model based off a biological neural networks, and the neural network as you have seen in the previous video series, it consists of input layers, output layers. Under the case when we discussed on the single layer networks, and if we go with the multi-layer networks, we will have an input layer, hidden layer and output layers, and all are connected by weights. And in the input is feeding the informations through the input x1, x2, xn through a weight w1, w2, wn, and through the activation functions to the output. That means within the layer it is getting summed up, and also it is being processed through the activation functions, whether it is falls under the linear or a non-linear functions. And that gives an idea about the building blocks. Now if you try to see this network building blocks, the network building blocks is being categorized based on the topology, and also based on the activation based on the weight that we consider, and also based on the activations. So that means topology is important. The second part is its weight adjustment, and third part it is the activation functions. So the network topology gives us an idea about different type of networks. That is what we are going to see in these slides. So type of neural networks. So the first we are going to discuss about the network under the case with respect to the feed forward networks. This is a feed forward networks because neural network types we are categorized under two classes. One is feed forward network, another is nothing but a feed back network. So feed forward network is the one which is feeding the x1 input and directly delivering to the output. And when we talk about a feedback network, that means it is not only giving processing the input to the output, but from the output it is being processed back to the input. So that's how we categorize. So let's see the these discussions. Now in the first point we are seeing the single layer feed forward networks. Now before we talk about the single layer feed forward networks, now about the feed forward networks we'll discuss. Now feed forward network is a non-recurrent networks. We normally non-recurrent means there is no feedback, that is it is input is given and it is going to deliver the output, and that is coming under this network topology. Now what exactly the network topology is, that it is basically an arrangement of a networks with the various nodes by interconnecting the lines, and these interconnecting lines creates the first single layer feed forward network. As you can see, the particular node is connected to the all other nodes of the output. Particular nodes of the input is connected similarly to the all other outputs, and particular node of the input is connected to all other outputs. You will not find any node of the input is connecting to the same nodes, or any output nodes is connecting to the same outputs nodes. So that's how the single layer. Now here you can see the concept. It is written that the concept of a feed forward ANN having a one weighted layer. In other words, we say that input layer is fully connected to the output layer. So that is known as a single layer feed forward network. Now coming to the multi-layer feed forward. So feed forward means there is no feedback systems. So all the connections with respect to the input and its weight will be flowing in a one direction. So it is moving in from left to right. You can take it into considerations. Now here for this figure. Now coming to the multi-layer feed forward network, you can see this one, the concept of a feed forward ANN having more than one weighted layer, as this network having one or more layer between the input and output, and it is called as hidden layers. So that means you have input layer, you have an output layer, you are having a middle layer which is termed as a hidden layer. So you are connecting each nodes to the next subsequent node. Like that, we are connecting every nodes to the next subsequent nodes. And when you are connecting these nodes, you are observing this one is that here there is a weight is there from this node to this nodes. Like that, a weight distribution is there. From the middle node or a hidden node to the output node, again there is a interconnections of the links are there, and these links are, when you are connecting it will be having a different weights. So these weights is being put together to creates the output. One important point you have to observe this one is that when you connect between the input and hidden layers here in this function, let us take a consideration that to this node, hidden node middle, all these three input is being connected. So x1, x2, x3, then its weight will be w1, w2, w3. So that is given to this one. So its weight is summed here. Assume that bias is not there. So when it is summed here, and then after this one, again the activation function will take place. Then output y will generate. That output y is nothing but the input for the output layer. So that's how. And here also you can take into consideration, here also y is producing, here also y is producing. These three things is taken together along with its weight. Again here it is summed together and plus summed together and plus bias. Bias is not there, so then followed by its activation functions, then it will produce its output. So that's how this middle layer is going to feed forward network is going to produce. So that's how the feed forward network under the single layer and a multi-layer network is being discussed. Now next comes the recurrent network. As I have termed here is that this is a non-recurrent network. This the next network is a recurrent network, and a recurrent network is that network which is termed as a feedback network. And in the feedback network, what exactly happens? The signal can flow in both directions. Here the signal will flow in both direction. Everywhere the signal will flow. That is known as a feedback network. But here you can see that it is flowing one direction, but it is not flowing within itself. Whereas a recurrent network, the signal will flow in both direction using a loop. And this particular case makes the things more complex, or nonlinear dynamic systems form it will work. So this is known as a fully recurrent network. So the recurrent network, they are the feedback network with a closed loop. Recurrent network is a feedback network with a closed loop. So you can try to see this one. Here every nodes are connected together, and every nodes are interlinked together. So that's how the network is being connected. If you see, that is a fully recurrent network. It is the simplest neural network architecture because all nodes are connected to all other nodes, and each nodes are both input and output. So that is known as a recurrent network. And Jordan network. Jordan network is that network where you can try to see that input is there, output is there, and hidden layer all are connected, and there is a interconnections between the input and output node is there. So that is being shown in this particular represent. So here it is termed, it is a closed loop network in which output will go to the input signal, as a feedback and the following direction. So actually this output is going back, so you cannot this arrow you neglect. It is going from output to input, so that is what it is shown. But if you are showing in this particular forms, then all are interconnected. So here this is another class of the network. So you can see that fully recurrent network and a recurrent network that comes under this class. So that is what you can see in this particular sections, which is being drawn in and another forms is that single layer feed forward non-recurrent network, a multi-layer non-recurrent network, single layer its own feedback recurrent network, single layer recurrent network, multi-layer recurrent network. So this is not a single layer recurrent feed forward network, non-recurrent network, which we have shown in the previous. This is a multi-layer network which we are showing input layer, hidden layer and output layer as in the form of a recurrent network. So that is what it is in the multi-layer with a non-linear activation functions. We'll be having a hidden layer. You see, normally we go with the hidden layer when we are not able to have a proper linearly separable conditions. So in that particular situations we are preferring for a third layers or the middle layer or a hidden layers. Now coming to the single layer on feedback. Single layer on feedback is nothing but this is what x to y, x and x, that returning back to itself. This is known as a feedback. AI to another if it is I, j, k, m. So I to j, j to AI, AI to AI, AJ to AJ. This is known as the feedback to its own network. So it will be having its own weights will be there. So you can consider as a fixed weight, and you can model this particular network for verifying the input and output. Another is a single layer recurrent network. As we have seen the previous figure, here is the output is fed back to the either the input or output is fed back to the output layer itself. So that's how we can able to have this form of a network also. Or output is taken and given to the middle layer also. So a single layer network with a feedback connections for a processing element, output can be direct back to the processing element itself or to the other processing element. So this is known as a recurrent network. Multi-layer recurrent network, you can try to see that you can have a multiple way of representing. So this is for a single layer. Now here you are giving output to the middle layer, and the middle layer also given the input x1. So you are having a 2 input to the middle layer. So this is known as a middle layer recurrent network or a feedback network or a feedback network. A processing element output can be directed back to the processing element or to the other processing element hidden layer in the same layer. So you will be having 2 inputs here, and that's what. So this how our network distribution is being discussed. Now we go to the next very important area. We are talking about different types of learning in the EN. Now what exactly the learning it indicates? See, learning is nothing but a training. We use the term in the machine learning, training. That means learning is one of the important components because that enables the network to learn based on the conditions. Say for example, you take an example with respect to a system is a child is learning. A child can learn by with the help of teacher. A child can learn with the help of in the absence of a teacher, or a child can able to learn by experience. So that is how we can use this particular training or learning mechanisms is being used. So here we have put 3 type of learning. One is supervised learning. What is meant by supervised learning or a supervised training? Actually, in a supervised learning and training, actually it provides the network with a series of inputs, and thereby it will try to see the output is being compared, whether it is output is being compared with the expected output or not. That means it provides the network with a series of input, sample input you can take, and comparing the output with the expected response. If the output is matched with the expected response, then we termed it as a supervised learning. We'll see in the block. The unsupervised learning, it is more or less a similar input vector assigned to the same output unit. So that means output vector will be having the same input vector. That is unsupervised learning. Reinforcement learning is what exactly it means. Here the right answer is not provided, but it is indicated whether it is right or wrong is existing. So you have to select among these two. So that means even if it is like a unsupervised learning, but some supervisory condition is being given, the indication is given right or wrong. So thereby the reinforcement learning is being performed. Reinforcement learning is basically having the attributes of supervised and unsupervised learnings together. Now let's see this particular learning in terms of a figure. Now here, if you try to see in the first case supervised input conditions, here input is given to a neural network, and the neural network is going to produce an output Y. And assume that this neural network is just like a teacher. This is a child which is learning. So that is how the child is learning with the help of a teacher's guidelines, and it is going to evaluated by the teacher to see that whether the child has attained that particular level or not. If the teacher expected output Y after putting an exam, if the child can able to achieve, then the teacher will give 100 out of 100 mark. Otherwise, teacher will say that okay, there are some error is there between the what the teacher expected and what was the actual output. And if that two difference, if the teacher measures the difference between actual output and the response output or the desired output, if that error, teacher will again teach the students and ask the students to learn further. So thereby students will again appear and thereby produce the similar output where the error is equal to 0. So that is known as a neural supervised learning. So in the supervised learning actually, or a training, the artificial neural network collects the input vector and present to the network, and there how that output vector will be generated for the given input. And this output vector is compared with the desired output vector, and if there is a variation, an error signal is generated, and this error signal is nothing but the difference between the actual output and the desired output, and this error signal is given for a weight adjustment to the neural network, and that's how the neural network will further collects the input with the new weights. It will produce the output. So this supervised learning is one of the learning mechanisms of the artificial neural network, and you have to remember that this learning artificial neural network learning mechanism, it is the basic method to modify the weight connections between the neurons. That is, you are changing the neurons weight, and learning is basically adjustment of the weights in the neurons. Now the second is nothing but unsupervised learning. Now what exactly is the unsupervised learning? unsupervised learning is that learning where you are not having any teacher to guide it. You learn by itself. So that is the things what you can see in this case of unsupervised learning. That means without the supervisions of any teacher, the learning process is an independent. Now here in this case what happened during the training the artificial neural network under the unsupervised learning case, this input vector is combined to form a output vector. And this input vector, when the new input pattern is applied, then the neural network is going to produce the output according to the new class of the input patterns. So that's how this input to the output is being checked. So if you are changing this one, accordingly this one will also change. So that is unsupervised learning is that. But here the problem is that if the in the case of unsupervised case, you basically you will not able to find if the input pattern is not found, then the new class is generated. So that is the conditions. You are not doing any other form of comparisons. So when a new input pattern is applied to the neural network, it gives the output response, indicating that the class to which the input pattern belongs. So that's how this particular unsupervised condition is there. And under this conditions, the desired output, whether it is a correct or incorrect, because there is no particular feedback systems to verify this unsupervised learning systems try to shows the variations with respect to the input output results. So this type of a learning, the network discovers the pattern and the features of the input data and the relations of the input data to the output. That's how this particular unsupervised condition it is going to check it under this particular conditions. Now coming to the third, the reinforcement case. Okay, before going to reinforce, one more point you have to understand is that since in the case of as I stated is that the input and output measurement is that in the case of unsupervised learning, here there is no labeling system is there. So it is based on the clustering cases, the unsupervised learning it follows. Now coming to the reinforcement learning, where you try to find that the input is there, it is just like a supervised learning, input and output is there, but only one factor is there. In place of a desired output, the reinforcement signal is being stated. Now actually this type of learning systems is to strengthen the network. Now how it is going to vary is that after every time it is going to train itself based on the its input, based on the output and based on its learning learning capabilities, and based on the learning capabilities, whatever the variation it is being noticed, that error signal is being fed for the neural network's weight adjustment. So here during the network training of this network under the reinforcement learning, network always receives some feedback from the output. So this makes the just like similar to the supervised learning. However, the evaluations in this case is not instructive just like the supervised learning, because after receiving the feedback, the network performs the weight adjustment, and that weight adjustment, it will keep on adjusting the weight and it will try to see whether the error has reduced or not. But that error reductions under the case of a supervised case it will be much faster as compared to the reinforcement learning. So these particular learning mechanisms is a part which supports the ML, because when you talk about the ML, there is a training is there is a testing is there, model generation is there, and then a prediction is there. So that's how this learning helps the systems to identify the whether the output is actually follows the input for a desired results or not. So with this I conclude here with respect to the discussions on the different learning mechanisms. Thank you.